Functions and their graphs is Unit 5 of the course Applied Algebra or APA. There are 7 objectives in this unit. Objective number 1, find the slope of the line given its equation or given 2 points on the line. Example number 1, find the slope of the line y equals 3x plus 5. So our equation is written in the form y equals mx plus b, or slope-intercept form. So m here is our slope. So therefore, the slope of this line is 3. Example number 2, find the slope of the line 3x plus 7y equals 1. So our equation is written in the form ax plus by equals c, or standard form. So the slope of the line written in standard form is negative a over b. So our a here is 3 and then our b is 7. The slope of this line is negative 3 over 7. Example number 3, find the slope of the line passing through 3, negative 5 and negative 1, 3. So this is our formula. M, or slope, equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So 3 is our x sub 1, negative 5 is our y sub 1, negative 1 is our x sub 2, and 3 is our y sub 2. So substituting these numbers into our formula, we have m equals 3 minus negative 5 over negative 1 minus 3. 3 minus negative 5 is 8, and negative 1 minus 3 is negative 4. So we have 8 over negative 4, and 8 over negative 4 is negative 2. So this is our slope. Objective number 2, determine the equation of the line in general form. A, given a slope and a point on the line. So if we are going to find the equation of the line given a slope and a point, we are going to use the point-slope form, which is y minus y sub 1 equals m times the quantity x minus x sub 1. And this is our general form. Ax plus by plus c equals 0. Example number 4, find the equation of the line whose slope is 2, containing negative 3 and 5. So using this formula, our m, or slope, is 2, our x sub 1 is negative 3, and our y sub 1 is 5. So we have y minus 5 equals 2 times the quantity x minus negative 3. So removing the parentheses, we multiply 2 times x and 2 times negative of negative 3. So that gives us y minus 5 equals 2x plus 6. Writing this equation in general form, so we are going to move y to the other side, so it becomes minus y. And then we are also going to move minus 5 to the other side, it becomes plus 5. So we have this equation, 2x minus y plus 11 equals 0. Example number 5, find the equation of the line containing points negative 4, 5 and negative 5, negative 1. This time we are going to use the 2 points form. So this is the equation, y minus y sub 1 equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1 times the quantity x minus x sub 1. So our x sub 1 is negative 4, our y sub 1 is 5, our x sub 2 is negative 5, our y sub 2 is negative 1. Substituting these numbers into our formula, we have y minus 5 equals negative 1 minus 5 over negative 5 minus negative 4 times the quantity x plus 4. Why plus 4? Because x sub 1 is negative 4. Now negative 1 minus 5 is negative 6, and negative 5 minus negative 4 is negative 1. So negative 6 over negative 1 is simply a 6. So we have y minus 5 equals 6 times the quantity of x plus 4. So removing the parentheses, we multiply 6 times x and 6 times 4. So that gives us y minus 5 equals 6x plus 24. So we are going to move y to the other side. It becomes minus y. And also the minus 5 we are going to move to the other side. So that's plus 5. So we have 6x minus y plus 29 equals 0. Example number 6. Write the equation of the line parallel to the line 3x plus 4y equals 6 containing 2, negative 3. So our solution, the slope of the line 3x plus 4y equals 6 is negative a over b, which is negative 3 over 4. So when we say parallel, the slope must be the same. So meaning to say, we are going to retain 3x plus 4y, and we will just find the c here. So we will do that. So that means 3x plus 4y equals a number c. And how do we find c? We will just use these numbers here, 2 for the x and negative 3 for y. Substituting these numbers into our equation, we have 3 times 2 plus 4 times negative 3. And the answer is negative 6. So meaning to say our c is negative 6. So we are going to write our equation 3x plus 4y equals negative 6. Writing this in general form, we have 3x plus 4y plus 6 equals 0. Example number 7. Write the equation of the line perpendicular to the line 3x plus 4y equals 6 containing 1, 4. So again, the slope of the line 3x plus 4y equals 6 is negative a over b, or negative 3 over 4. Now we are going to find the equation of the line perpendicular to this line. So when you say perpendicular slope, the slope should be the inverse reciprocal of the given slope. So if we have negative 3 over 4, so the inverse reciprocal is positive 4 over 3. Meaning to say we are going to change the sign, and also we are going to flip. The numerator becomes denominator and the denominator becomes numerator. So that means if we are going to find the equation, we will switch 3 and 4, and also we are going to change the sign. So we are going to write 4x minus 3y equals a certain number c. How are we going to find the c? We will again use this pair here, 1 and 4. So 1 is the value of x and 4 is the value of y. So substituting these numbers into our equation, we have 4 times 1 minus 3 times 4. And this gives us negative 8. So our c here is negative 8. So our equation is 4x minus 3y equals negative 8. And writing this in general form, we have 4x minus 3y plus 8 equals 0. Objective number 3. Solve applied problems involving slope as ratio or as rate of change. Example number 8. Abdulaziz climbs a mountain. After 2 hours, he is at an altitude of 200 meters. After 5 hours, he is at an altitude of 650 meters. what is his average rate of change? So the average rate of change is actually the slope, with the formula m equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So 2 hours is our x sub 1, 200 meters is our y sub 1, then 5 hours is our x sub 2, and 650 meters is our y sub 2. Substituting these numbers into our formula, we have 650 minus 200 over 5 minus 2. 650 minus 200 is 450, and then 5 minus 2 is 3, so 450 divided by 3 is 150. So therefore, the average rate of change is 150 meters per hour. Objective number 4. Determine whether a relation is a function or not. In this objective, let us take note that a function is a one-to-one or many-to-one correspondence, but not one-to-many. Example number 9. Is the relation shown a function? Yes or no? Yes. Why? Because it's a one-to-one correspondence. Notice here, 1 corresponds to 2, 2 corresponds to 4, 3 corresponds to 6. How about this one? Example number 10. Is the relation shown a function? Yes or no? Yes. Why? Because it's a many-to-one correspondence. So we have here many, 1 and 2 corresponds to 4, and of course 3 corresponds to 6. This is 1-to-1. This is already function. Example number 11. Is the relation shown a function? No. Why? Because it's a one-to-many correspondence. So notice here that the number 2 corresponds to 2 and corresponds to 4. So 1-to-many. Example number 12. Is the set of ordered pairs shown a function? 1, 2, 3, 4, negative 3, 6, negative 4, 7, and 10, 11. The answer is yes. Why? Because it's a one-to-one correspondence. For every value of x, there is exactly one value of y. How about example number 13? Is the set of ordered pairs shown a function? This is the set of ordered pairs. 1, 2, 3, 4, 1, 5, 2, 6, 3, 7. The answer is no. Why? Because it has a one-to-many correspondence. Where is that? Notice here that 1 corresponds to 2, and also 1 corresponds to 5. So this is one-to-many. So this means if we are given a set of ordered pairs, x cannot be repeated, or else it will give a one-to-many correspondence. Example number 14. Is the equation y equals 3x plus 5 a function? Yes. Why? It's because the correspondence of linear equations is 1-to-1, meaning to say for every value of x, there is exactly one value of y. Example number 15. Is the equation x equals y squared minus 4 a function? No. It's because the correspondence of this equation is one-to-many. How? For example, if we are going to substitute y with 1, so that's going to be x equals 1 squared minus 4. That gives us negative 3. And also, if we are going to substitute y with negative 1, we have x equals negative 1 squared minus 4. It is still equal to negative 3. So that's going to be one-to-many. Objective number 5. Evaluate functions including piecewise functions. Example number 16. Given the function f of x equals x plus 3 if x is less than or equal to negative 2, x squared plus 3 if negative 2 is less than x is less than or equal to 0, and x squared minus x plus 6 if x is greater than 0, find f of x. So notice here that 6 is in this domain, greater than 0. So meaning to say we are going to evaluate the function x squared minus x plus 6 at x equals 6. So we have f of x equals 6 squared minus 6 plus 6. 6 squared is 36 minus 6 plus 6. So our answer here is 36. Example number 17. Given the same function, find f of negative 4. So negative 4 is in this domain. So that means we are going to evaluate x plus 3 at x equals negative 4. So therefore f of negative 4 equals negative 4 plus 3. And negative 4 plus 3 is negative 1. Objective number 6. Identify the domain and range of a function. Example number 18. Give the domain and range of f of x equals 3x minus 2. So this is the graph of f of x equals 3x minus 2. So it's a line. The domain is settable real numbers because this line can be extended infinitely to the left and infinitely to the right. Our range here is settable real numbers because this line can be extended infinitely downward and infinitely upward. Example number 19. Give the domain and range of the graph f of x equals x squared plus 4x plus 3. So this graph extends infinitely to the left and also infinitely to the right. So the domain is settable real numbers. How about the range? So if we don't have the graph, we need to find the vertex first. How? We are going to write our equation in standard form. How? Okay, we are going to put in parentheses the terms with x and then the constant outside, and then we are going to complete the square inside the parentheses. To complete the square, we are going to find half of 4 and then square it. So half of 4 is 2 and square it is 4, so we are going to add 4 here, and because we added 4 inside the parentheses, to compensate that, we are going to subtract 4 from outside the parentheses. And because we completed the square here, it can be written as square of a binomial. So it looks like the quantity x plus 2 squared, and then 3 minus 4 is negative 1. And the vertex here, or the turning point, is negative 2, negative 1. This point here. Now when you say range, we are going to look at it from the lowest point to the highest point, or from the highest point to the lowest point, because our graph opens upward, so this is the lowest point here. And therefore the range is y is greater than or equal to negative 1. So meaning to say from negative 1 going upward. Example number 20. Give the domain and range of f of x equals negative x squared plus 6x minus 5. This graph extends infinitely to the left and infinitely to the right, so our domain is settable real numbers. Now to find the range, we are going to find first the vertex, especially if we don't have the graph. Again, to do that, we are going to put inside the parentheses the terms with x, and the constant outside the parentheses. Notice here that because the coefficient of x squared is negative, I have to bring it outside. So this means this positive 6 will be affected. It becomes minus 6. Now we are going to complete the square. To complete the square, we are going to find half of 6, which is 3, and square it. So 3 times 3 is 9. So we add 9 here, and we also have to add 9 outside. Why not subtract 9? Because if we are going to consider the negative outside here, if we are going to multiply back, so this is negative x squared, this is positive 6x, then this is negative 9. So we added literally here negative 9. So we are going to add positive 9 outside the parentheses. Now we can write this as square of a binomial 3. It becomes negative times the quantity x minus 3 squared plus 4. Plus 4 because negative 5 plus 9 is 4. So our vertex here is 3, 4. It's here. Our range here is y is less than or equal to 4, meaning to say from 4 going downward. Objective number 7. Use the vertical line test to determine whether a graph represents a function or not. So example number 21. Using a vertical line test, which of the following graphs represent a function? So with a vertical line test, if we can draw a vertical line that can intersect the graph at more than one point, that is not a function. But if that vertical line crosses the graph at exactly one point, it's a function. Here, we draw a vertical line, and the vertical line passes or crosses the graph at exactly one point, so it's a function. Here also, for B, if we draw a vertical line, it crosses the graph at exactly one point, so it's a function. Here, if we are going to draw a vertical line, it crosses the graph at 2 points. So this is not function. Thanks for watching, guys. This is Teacher Rejil. Keep safe.